how has recent rare earth price volatility affected your design requirements?
Yeah, price volatility is great. A lot of contract negotiations. But from a motor designer standpoint, you know, in this room, it's what trade-offs do you need to make for your program? You have program requirements that go into how you're designing your motor, right? You can't always do the F1, Formula One, you know, kinetic energy recovery system, carbon fiber sleeve, laminated N52, super dysprosium diffused magnets with, you know, the Vacuperm or a Carpenter 49, Cobalt. You can't do all that for every one of your systems, right? So what are those cost trade-offs, and how is my rare earth volatility playing with my design inputs to make sure that my program has its financial performance over the life, or its performance over the life of it? So I'd say the volatility comes back to a little bit of the motor designer. How do you make sure that you can deal with that volatility over the life of the program? So your program engineers, program directors have to work with you, but you may do things like, I know it sounds weird, but you may make some trade-offs. Maybe I can give up a cobalt steel and just use a regular non-grain oriented silicon steel, but maybe I can make it thinner, so I can still get pretty good performance, and I'm giving something up, but I'm saving costs, and I'm still got a pretty good magnet. I can use, if it's high volume enough, can I use dysprosium diffusion? Can I go to this, you know, category? You're gonna look at trade-offs to make sure that these commodities, being cobalt, dysprosium, neodymium, I mean, copper's copper, there's not too much you can do about it, but those really high cost driving materials, you're gonna look for what can I give as a motor designer to make sure that if we have another crisis or another bubble, which I know we will, right? We've had two now, that doesn't affect your program, you know, your company's program to too much of a degree.